In this video, I'm going to talk about one of the mistakes that students do in hypothesis testing while working with the test of significance approach. So let's say the estimated equation that we have is y hat equal to 24 plus 1.3 xi. In this estimated equation, this 24 is beta 1 hat and this 1.3 is beta 2 hat. So basically this 24 is the value of the intercept estimator and this 1.3 is the value of the slope estimator. Now one of the mistakes that I have seen students doing is that if they want to do hypothesis testing, they write something like this. So they write null as beta 1 hat equal to 0 and alternative as beta 1 hat not equal to 0. Or they can also work with this. Okay. Now let's understand what is wrong in writing the hypothesis in this manner. Basically, the hypothesis that you have, it should not be based on the estimator. So in this case, you are saying that the null hypothesis is beta 1 hat is equal to 0. I mean, think of it in this way that beta 1 is the intercept parameter. Okay, so this is the intercept parameter. And beta 2, this is the slope parameter. So this is the slope parameter. Now beta 1 and beta 2 are the true things that we do not know. So we are trying to estimate beta 1 and beta 2. And this beta 1 hat and beta 2 hat that we are working with, these are actually the estimators of beta 1 and beta 2. Now when we work with beta 1 hat and beta 2 hat, you already know the values of beta 1 hat and beta 2 hat. So when you already know the values of beta 1 hat and beta 2 hat, why would you hypothesize about these things? Okay, so we never write the null hypothesis and the alternative hypothesis on the estimators. Whenever you are writing the null hypothesis and the alternative hypothesis, you have to make sure that you are writing these on the population parameter. So this is absolutely wrong. What you can write instead of that is beta 1 equal to 0 and the alternative is beta 1 not equal to 0. Similarly, this is absolutely wrong. You cannot hypothesize about the value of the estimator. You get to observe the value of the estimator. You hypothesize about the value of the population parameter. So you can write null as beta 2 equal to 0 and alternative as beta 2 not equal to 0. Okay, so this is one of the things that you should keep in mind, that whenever you are doing hypothesis testing and whenever you are writing the null hypothesis and the alternative hypothesis, make sure that you are not writing these on the estimators and you are writing these on the population parameters. Okay, now let's say if you are writing the T formula, then the T formula is estimator minus the hypothesized value. So estimator minus the hypothesized value divided by the standard error. SE means the standard error. So divided by the standard error of the estimator. So let's say that you are working with this scenario. Okay, so we are working with the null hypothesis beta 1 equal to 0 and alternative beta 1 not equal to 0. So in this case, the T is equal to, instead of estimator, you're going to write beta 1 hat, because that's the estimator of beta 1 and you're already given the value of beta 1 hat actually, which is 24. So in the next step, if you want, you can substitute this value over here minus the hypothesized value. See, by the hypothesized value, I mean the value that is there under the null hypothesis. So under the null hypothesis, we are saying that the value is equal to 0. So this hypothesized value is actually equal to 0 divided by the standard error of the estimator. So once again, we are hypothesizing about the value of beta 1. So the estimator is beta 1 hat. That means in the denominator, you have to write standard error of beta 1 hat. Now see, there are a couple of things that you need to note in the T formula. So when you're writing the T formula, the first term is the estimator and in the denominator, you have the standard error of the estimator. Do not do this mistake of writing standard error of beta 1 in the denominator. It's standard error of beta 1 hat in the denominator. Basically, there is nothing called standard error of beta 1. I mean, think of it in this way, that what is beta 1? Beta 1 is an intercept parameter. Basically, the intercept parameter that I'm talking about is only a single value. Intercept parameter does not have multiple values. It has just one value, which is actually the true value. The only thing is that we do not know that value. So these values that you see over here, beta 1 and beta 2, these are constants. Okay, these are only one single value. The issue is that we do not know these values, so we are trying to figure out these values using some methodology. Okay, so standard error of beta 1 is not going to make any sense, right? So when you write the t formula, just be careful that in the numerator you are writing beta 1 hat minus the hypothesized value, which is this value over here, that is under the null hypothesis, divided by the standard error of the estimator. Okay,